is the first. The second is what? The second is infinity by infinity. Okay? Infinity by infinity. So infinity by infinity for this indeterminate form. Okay? For this indeterminate form, so we have what? We have a question. We have a question if limit x approaches fx approaches infinity. Okay? Approaches infinity. So here this is infinity. Okay? This infinity means here can be plus infinity or minus infinity. Okay? So this means what? This means limit x approaches fx approaches plus infinity, or limit x approaches fx approaches minus infinity. Okay, minus infinity. Okay, so here if x approaches fx approaches plus infinity, and limit x approaches gx approaches infinity. Okay, infinity. So what about the limit x approaches fx by gx? So what about this limit? What about this limit? What about this limit? So here, okay. Here the question is x approaches fx approaches infinity, x approaches gx approaches infinity. So what about the limit x approaches fx by gx? So what about this limit? What about this limit? For this limit, okay. For here, actually we have a name in mathematics. In mathematics, we call this form as the indeterminate form of type infinity by infinity. Okay. For this form, okay, we call it the indeterminate form of type infinity by infinity. Infinity by infinity. So what about this indeterminate form? We also have the L'Hopital's rule. Okay. We also have the L'Hopital's rule. So the L'Hopital's rule for this form, okay, is what? Is here is the same. Okay. Here is the same, and here it is limit x approaches g fx approaches infinity, and x approaches gx approaches infinity. So here, if x approaches f prime divided by g prime exists, or this limit is plus infinity or minus infinity, then we also have this conclusion. Okay, we also have this conclusion. So actually here. You understand? Okay. We also have for this indeterminate form. We also have the L'Hopital's rule. Okay. We also have this L'Hopital's rule. So here for this here we give a remark. Just here. Okay. Here. We have 1 minute. Okay? We have 1 minute. For this L'Hopital's rule means that if this limit exists, then we have this convolution. So we have a question: if this limit does not exist, so what about this limit? So we give an example. Okay, we give an example for this example. For this limit. Limit x approaches plus infinity, x plus sin x divided x. So now we can this limit we can see when x approaches plus infinity, this limit equal to what? This limit, okay? So here this limit actually we can divide it as limit x approaches plus infinity Here is what? Here is x by x, yeah? X by x is 1. 1 plus sin x by x, yeah? Equal to here? Yeah. And here we can see sin x. Sin x, we know that is between -1 to 1, yeah? So here is bounded, yeah? Here is bounded, but here x approaches plus infinity. Here is plus infinity. So this limit actually is what? This limit. We know, okay?
1.
1? No. Here is x approaches 0, sin x divided x. This is 1, okay? X approaches 0. This is 1. But here x approaches plus infinity. But still different, okay? So here for this one limit, we can see sin x greater than -1, less than or equal to 1, yeah? So here we have what? So here we have sin x by x greater than -1 by x, less than 1 by x, yeah? So when x approaches plus infinity, this approaches what? This approaches 0, yeah? And here this approaches what? When x approaches plus infinity, 1 by -1 by x approaches what? 1 by infinity plus infinity. 1 divided by 0 is also 0, yeah? 0. So the left is 0, the right is 0, so we use the squeezing result. So here this limit is what? 0, yeah? So this limit is 0, this limit is 1, so this limit actually is 1, yeah? So this limit is 1. But now we can see this one, okay? So here is where x approaches plus infinity, this is approaches plus infinity, this is also approaches plus infinity. So here is what? Here is indeterminate form, infinity by infinity. So here we can use what? We can use the indeterminate. We can use the L'Hopital's rule. So we use the L'Hopital's rule. Here is what? Here is the limit x approaches sin x. This prime divided x prime. X approaches plus infinity. So this is equal to what? Limit x approaches plus infinity. So here is 1 plus sin is cosine, yeah? Cosine is here is what? Here is 1, yeah? So this is the limit x approaches plus infinity, 1 plus cosine x, yeah? So x approaches plus infinity, this limit does not exist, okay? Does not exist. Does not exist. This limit does not exist. So here, this example, tell us that. Tell us what? Tell us that when limit x approaches a f prime g prime, this does not exist. If this limit does not exist, but this limit exists. Okay, so here tell us this conclusion, okay, this conclusion. When this limit does not exist, this limit also can exist, okay? So this conclusion means that if this limit exists, they are the same. If this limit does not exist, so we do not have this conclusion, okay? So I think that hyperbolized, okay? Hyperbolized. We begin at 4, okay? We begin at 4.